Okay, the following is the theory behind the neutrino-induced antimatter reactor. I call it the MARLEY reactor, after Bob Marley. Couple points. This is the most powerful electrical generator that's possible, says E equals mc squared, because we're converting matter directly into electrical energy. Well, into energy, then electrical energy, so I guess it's not really directly. It runs on water, and it's intrinsically safe. So that means, at least with this, if the reaction is not perfectly balanced, it doesn't happen at all. So that negates any possibility of any overload or cascade type of failure. For starting off, we need water, and we need to separate it into its component gases. You do this by applying a small voltage to two terminals, or electrodes, in said water. It will separate it into hydrogen and oxygen. Alright? So we need to make a generator that does that. Basically, you're going to have bolts, stainless steel. Don't use any sort of mild steel or aluminum, but stainless. The plates will be graphite because they will hold up the best. And what you do is the configuration, these are going to be square plates with a bigger hole drilled on the top left and a smaller hole drilled on the top right, so that when the electrode goes through the plates, you want it to make contact with every other plate on one side, and then exactly the opposite on the opposite side. So you have to have insulators to keep them separated. You want probably a nut on either side there, because you want this whole section to be one solid unit. You don't want these touching. The gas that it produces is extremely volatile. Even the slightest spark can set it off, which is why you have this as a flashback protector. Basically, as the gas builds up, it goes through this tube, through water, and then out to here. The reason why you do that, if there's any spark anywhere on the output, it cannot travel back into the tank where it subsequently blows the thing up. Alright, the other thing is you probably want a separate supply tank from your electrolysis tank, and you can use just a simple siphoning method for that. You don't even really need a pump. Alright, so this will produce, with its current configuration here, a lot of hydrogen, oxygen, HHO gas, and we now need to separate that to get just the hydrogen out. So how I do that, to make sure you're getting pure hydrogen and nothing else from that reaction, you are going to pass the gas through a tube, and basically you have an electrode on either end here, and it comes to a T, and you have another electrode here. So you electrify the gas using high voltage. In this case, you're adding static electrons to the gas, and you have a high voltage of the opposite polarity on the other side. So what this is going to do is it's going to accelerate the gas really, really fast from meow to meow. You have the same kind of setup here, but the idea is that the oxygen, having a lot more mass, is not going to be able to make the 90-degree angle turn like the hydrogen will, having a much smaller mass. So you can actually control the purity of your gas by changing the voltage on these two plates. What you want it to do is have it to where you're just barely getting the hydrogen off here, so you will have a little bit of hydrogen leak out through here. This will ensure pure hydrogen on your output. Now that kind of creates a problem since it's extremely volatile. You're going to want to make sure your output is ignited either via a glow plug or some sort of spark gap. And of course you're going to want to control the flow of your output as well. So that leads us to the next point. You now need to strip the valent electrons from the hydrogen. So you do that via thermionic electron stripping method, which is just a fancy way of saying you pass the hydrogen into a tungsten tube where you heat the unholy heck out of it, and that causes the electrons in the tungsten to boil off, and that creates a high voltage potential, which, if it is high enough, it will strip the valent electron off of the hydrogen. Okay, so you have all these free electrons now. This is ideally in a vacuum. You have infrared, and this is going to be coming from a part later on in the tutorial here. So you have infrared light coming and reflecting off this reflector here and focusing onto part of the tube, the tungsten tube here. You can also assist that heating by using high current electrodes. Of course, you don't want them to completely block the path of everything here, so they'll have to just come in, they'll have to be relatively small. Anyway, so that is going to create output of pure protons, and you have now stripped its valent electrons and created free electrons in the process. You can also push these free electrons up by having a high voltage negative potential on that reflector. Alright, next part. You need to condense the proton stream so that as you look down the stream, your cross-section is dense enough to where there's few to no spaces where anything can travel between them. So you could do that by a standard electromagnet or something like neodymium, but it's more likely that you're going to need something even stronger magnetic field-wise. So for that, we can take the free electrons and spiral them into a helix around the tube. You do that by having a high voltage potential on the outer walls and a high voltage pushing from the reflector up, and then you also have to focus them into a line, and that will start a spiral path. This will create an even better magnetic field than what you could get with any sort of standard electromagnet. Because the density is going to be a lot greater, the speed is going to be much greater. Since it's a vacuum, you have almost no resistance. Alright, that will force protons into a very dense stream, which leads us to the next part, the reaction core. Because these photons have such a high cross-sectional density as you look down the stream, that means that neutrino collision now becomes likely. If this reactor is pointed in the direction of the sun, which is our best producer of neutrinos, what's going to happen is some of those neutrinos will start to collide with the protons. When it collides with the proton, it converts it into an antiproton, which is where the fun happens, because now the protons and antiprotons will collide together, creating two gamma-ray photons. Gamma-ray photons are at the highest end of the EM spectrum, so that's your gamma conversion. Now, you take the free electrons from the helix, and you impact them with the gamma-ray photons you just made, and then you have an effect called the inverse Compton scattering effect, which basically means since these electrons are at a lower energy state than the photons, there's going to be a trade-off where the electrons lose or gain some energy and the photons lose some energy. Ideally, you want the photons to drop all the way down to the infrared spectrum, which is where you send them back and reflect them back towards the tube from the earlier part. The electrons are going to be moving very, very fast at that point. You need to strip them off into tubes by using, you could use a combination of high voltage and electromagnetic or just magnetic tubes. And that will strip the electrons into a stream because you don't want them to impact the infrared photons as they are sent back down to be reflected. Because if you do so, you could possibly have another reaction, even though they should be at relatively the same energy state. You don't want any of the photons to come out without being reduced to infrared. Otherwise, you'll have X-ray and gamma shoot right through the top of the containment chamber. That's not good. Alright, that leads us to the last part, energy conversion. The free electrons that are now moving very, very, very fast are going to be moving through a basically a vacuum conduit, if you will, and you'll have magnets to keep the stream from hitting the walls and to direct it. To convert that energy, you can pass it through a section that has basically a solenoid. It's just a coil, and that will slow the electrons down, because if that coil is loaded, the magnetic field, the magnetic moment from these fast-moving electrons will be translated to a subsequent current on the load, slowing the electrons down, where you can then collect them with a tungsten plate. Alright, so design considerations: definitely have a Geiger counter, a permanent one, on the top to make sure you're not having any gamma or X-ray that's coming out the top. The other design considerations would probably be, let's see here. Yeah, your water, it will have to be slightly conductive. That was an error in a previous design. It really shouldn't be pure. But be careful with your voltage here, because if it's too high a voltage, it will destroy the plates. And that is about it.